Hello everyone, I am Masood Ibn Abdul Wahid. In today's class, we are going to discuss about the solutions of some electric network problems. So let us choose the topic of today's class as circuit reduction or network reduction. So we will go into the first problem. So this is a very simple one. Find the equivalent resistance of the circuit shown below. And the given network is this one. You can see it to be very simple. But why I selected such a simple circuit is, so some of you have asked for a detailed video how to simulate the given circuit diagram in the Proteus software. So what I have decided for today's class, let us take a simple circuit, let us solve it manually, and right from the scratch, we will draw this in the Proteus software, right from the first step. And I will guide you step by step how you can draw a diagram and how to simulate, how to pick the components, everything. Okay. So now first manually we will complete the solution of this problem. So the given problem has three resistances, each of 30 ohm. So they have asked to find the equivalent resistance of the given network. So to find that, first we have to analyze the circuit. So let us name some nodes in the given circuit. So as I have shown to you, this is node number A, B, C, D. So just by seeing the diagram, you could not come into a conclusion that whether this is connected to be in parallel or in series. So maybe if you could have solved many problems, you can just straight away go into the direct solution, or you can just have a glimpse of the circuit and you can decide what is the connection to be. But for the beginners, let me redraw the given circuit in a different perspective. So for redrawing, just we will have one point to be noted, that the points A and B, in one way it is connected with the two resistances, but in the other way it is short circuited. The voltage difference between those 2 points will be 0. And in the same case, the point B and D are again short circuited. So here also there is no potential difference between the point B and D. Let me redraw the circuit by having the point that A and C, B and D are short circuited. So that A and C are in the same potential, B and D are in the same potential. So we can consider this point A and C to be together. We can merge it. In the same way, B and D, we can merge it. So by this discussion, we come to a conclusion that we are going to merge the points A and C, and we are going to merge the points B and D. Okay. Now connect the three resistances as given in the circuit. So there will be a resistance between the points A and B with 30 ohms connected, and there will be another resistance between B and C with 30 ohms. So here once again I am saying points A and C are merged together, so there will be one more resistance between the same 2 points with 30 ohms, like this. And the third resistance between C and D, once again B and D are in the same potential, so we merged together, and now between the C and D you can have one more resistance in this way. Now we are in need of finding the equivalent resistance of these three resistances, each of 30 ohm. So this R equivalent we have to find. For finding R equivalent, we should know what is the connection between this, and to know what is the connection between these three resistances, let us supply a current. Let us assume that we are supplying a current in this way. So after getting out of this point, the current will go and reach the point A or C. Until this point, there is no problem, there is only one path. After this point, the path is diverting into three ways. One is through this resistance, another is through this one, and another is through this one. As the current is dividing into three parts, now we can come to a conclusion that these three resistances are in parallel. Already you could have studied that the equivalent resistance of parallelly connected networks is given by 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Here all the resistances R1, R2, R3 are of equal values 30 ohms. So 1 by R equivalent is equal to 1 by 30 plus 1 by 30 plus 1 by 30, which implies 1 by R equivalent is equal to 3 by 30, which may give you 1 by 10. 1 by R equivalent is equal to 1 by 10, which in turn R equivalent is equal to 10 ohm. As I begin the solution of this problem with the word, it is a simple one. So the solution will be simple. Just you have to know this, how to redraw this given network into a simple one. As requested by some of you, I'm going to draw this in the Proteus software. You can see in the screen, we have launched the Proteus software. From here, I will guide you step by step. So go to the new file. You can open it new file here or from the file menu, or you can click this also. In these three ways, you can open up a new file, new project. You have to give the name for the project. So let us name it as network reduction question 1, and you can save it in any place as you like. I am saving it in the downloads. Select folder. So click the next. Here you have to select the size of the schematic what you need. So if you want to, first you have to create. So it is asking a question in this tab, in this window, it is asking that whether you need to create a schematic design or not. Yes, we have to create. So create a schematic. You can select the size of the workplace, whatever you want. Next, in this tab, it is asking for whether we are going to create any PCB out of this schematic what we are drawing now. So as of now, we are not going to create any PCB. So we need not bother about PCB layout. So do not create a PCB layout. This is the option you have to give. Next, in this tab, it is asking for a question that whether we are using any microcontroller in the schematic or not. Of course, we are not going to use any microcontroller. So by default, it will be no firmware project. So leave it as such. Click next. Now it will give you the summary, whatever the options we have selected. We have created the schematic and we didn't created any layout and we didn't use any microcontroller firmware. You can see that here, and you can see the details also here, and you can see the path where the file is going to be saved. So now finish it. Now you will end up with this workplace. This is the workplace for creating our schematic design. Now we are in need of bringing the components what we are going to use. So now we are going to pick the devices. For that, click the P. P means pick devices. There is a shortcut for this. So that is, you can press the button P in your keypad. After coming here, first we need is resistance. Okay. You can type it to be resistance, or you can just type RES. Okay. The resistance will come here. So this resistance, if you want to take it to the workplace, you can click. Once you click, it will become blue engaged and you can click OK. So what the difference is, if you want to get any other items, if you want to continue the pick devices, once you click OK, the tab will go off. Okay. Again and again you have to click this pick devices. So in other case, what we can do is, whatever the element or whatever the device you want to pick, let me take a battery just for showing you I am doing this. So let me take an active battery cell. What I can do is, if I am going to continue the pick devices, what I can do is I can double click this. Okay. I can double click this. Once you double click, you can see all the items whatever you are picking, it will be listed here. Also, the difference between the previous method and this one is, so once you do double click, the item will be listed in the devices list, but the pick devices tab will be available for us. But once you click OK, the pick devices tab will be closed. So this is the difference between double click and the single click OK. Let us take the resistance into the workplace. So for taking that, you can click the resistance and you can bring the mouse inside the schematic layout, inside the workplace, and you can click one time. The resistance will be available here for you to place in whatever the place you want. Okay. You can just scroll the mouse here and there to place it correctly exactly where you want. Okay, let me place it here. So after deciding the place where I want to keep it, just stop scrolling and click one time. Okay, now the resistance is placed here. Assume you are going to place 10 resistances like this. So you need not go and click every time. Once you click one time, that resistance will be available inside this. So you can keep n number of resistance, whatever you want. Okay, so that will be always available within the scope. But of course now we are going to place only 3 resistance. Just to show you I did this. Let me erase this. Let me connect the second resistance, this is R2, and let me connect the third last resistance, this is R3. So now for better visibility, let me zoom it. So how I am zooming is I am using the scroll wheel up and down. And this green color box you are seeing here, so this will be the current active window, what we are able to see. Change the resistance value. For changing, what you can do is you can right click and you can edit the label. The other way is just double click the 10k, and the resistance what given is 30. So instead of giving 30 ohm, you can stop it with 30 itself. Okay, that doesn't make a difference. So here also the resistance is of 30 ohm. Here also the resistance is of 30 ohm. Okay. Now let us connect this. So for connecting, so let it be here. I have double clicked for stopping the wire here. The green color line is the wire connections. Okay. So to do the connection, what you have to do is wherever you want to take a wire from, so go keep the cursor near to that point. A red color box will be displayed to you. From there you can click one time and you can drag the wire until the point where you want to connect, and click one more time. So the wire will get connected. And same thing, bring the mouse near to this point, you will see a red tiny box opening, and you can click one time and you can drag the wire and you can go to the resistance, other resistance one end, and you can click another time so that it will be closed. And you need a wire from here and you need to keep it here. Okay, so now the points A and C to be short circuited, so that is this one, so this one, and points B and D need to be short circuited, that is this one. Okay, let me stop here. The given circuit diagram is constructed into the Proteus. Now we have to run it and we have to see what is the equivalent resistance offered by this network. So now you are in need of getting a ohm meter to measure the resistance of this network. Go to the component mode, click on P, or otherwise you can go directly by pressing the key P. Type ohm meter. So this is the ohm meter. We are going to use it. Double click this. Okay. Now take the ohm meter into the required place. So let us measure it in this place. Now you need to short circuit these 2 points and you need to short circuit these 2 points. Now connect these 2 ends to the ohm meter like this. Now the circuit is constructed, ohm meter is connected. Now you can run the simulation to see the resistance what it is offering. So you can see the ohm meter display, it is 10 ohm, which is what we have manually calculated. So I think you will have a better view now. Here we are. So this is what we have manually calculated, and just now we completed the simulation of this. Let me go into another network which is for the same topic, circuit reduction or network reduction. This is also a university question. The question says, find the range of Rin for the circuit shown below. So instead of finding the R equivalent value, here they are asking for what may be the range of the resistance Rin for the given circuit. So the circuit is this one. So they have connected 5 resistance in series and parallel combinations. Out of that, 4 resistance were indicative values 1, 2, 3, 4, but one is given to be resistance R. Now we are in need of finding out what may be the range of the resistance R in by looking through these 2 points. The lookover point is between this two. So we have to look in this side and we have to find the equivalent resistance of this area between these 5 resistances. Okay. So instead of directly going into the circuit, let us, because now the solution will become step by step. So we are in need of numbering the resistance values so that it will be easy for us to call out the resistance. So let the resistances be called as this. Resistance R is called to be R1, 4 ohm resistance is called to be R2, 3 ohm resistance is R3, 2 ohm resistance is R4 and 5 ohm resistance is R1. And since we are looking from this side, always we have to reduce the network from the opposite end, from the end through which we are looking into the network. So we are looking into the network from this end. So we have to start reducing the network from the opposite side, which is this one. So we have to reduce the network from this way. Okay. So let us find the equivalent resistance. So to find out the mode of connection between the resistance, as usual, let us pass a current in this way. So let us pass a current in this way until this point. The current will be same. After this point, the current will get diversified in 2 ways. One is through this 2 ohm resistance, another is through 1 ohm resistance. So these two are connected in parallel, and the current which is entering into the 2 ohm resistance will go until this point, and after this point will be bifurcated through this way and this way. So the current flowing through the 4 ohm resistance will go up to this point, and after this point the same current will be going through the R ohm, because there is no other path here. So now wherever the current is dividing, so those paths are connected in parallel. Wherever the current is having the same value, those resistances are in series connection. So with this idea, we will go into the solution of the network. The equivalent resistance between R1 and R2. So you may ask why the solution is starting with this resistance, because we are seeing the network from this point. Okay. So we have to start the network solution, or we have to start the network reduction from this point. So between the resistance R1 and R2, the equivalent resistance we can find it to be R12. The R12 will be the addition of these two resistances, because those two are connected in series. So it is R12 equal to R1 plus R2, and it is R plus 4. Now we can redraw the network by combining these two. So let me take this reduced network to another slide. So now we are going to find the equivalent resistance of these two resistances. As I said, the current which is passing through 2 ohm resistance will enter into this point, and after this point it will be bifurcated into 2 parts. So these two are connected in parallel. The equivalent resistance of the parallel combination is 1 by R123 equal to 1 by R12 plus 1 by R3. By simplifying this, you will get 1 by R123 equal to 1 by R12 plus R3 divided by R12 multiply R3. R123 equal to R12 multiply R3 divided by R1 plus R3. So now you can put up the values of the individual resistances. R12 is R plus 4 and R3 is 3 ohm. So R12 multiply R3 divide R12 plus R3. So you can multiply this inside and you can add with this available R plus 4. So you will get as R123 equal to 3R plus 12 divide R plus 7. So now we have reduced these two resistances into a single one, by which the network will take a new shape like this. Let me take this new circuit. Now we are going to find the equivalent resistance between R123 and R4. Again, the current passing through the 2 ohm resistance will come up to this point, and after this point the same current will enter into this resistance, which is termed as R123. So these two are connected in series. So the equivalent resistance between these two will be R1234, which is equal to R123 plus R4, because those two are connected in series. By putting up the values, it is equal to 3R plus 12 divide R plus 7. With this, we have to add this 2 ohm resistance. Simplify the equation by which we will get the answer of R1234, which is equal to 5R plus 26 divided by R plus 7. So by combining this, we can redraw the circuit as given to you here. The current which is entering into the network will come up to this point, and after this point, as we discussed, it will bifurcate into two parts, one through R5, another through R1234. So these two are connected in parallel. The equivalent resistance between the parallelly connected two resistances are 1 by R2345 equal to 1 by R234 plus 1 by R5 as shown to you here. And by simplification, we can come up to this, put up the values. So R1234 is this value and R5 is 1 ohm. So here we have took the product of the two resistance, and here we have added the two resistance values. By simplification, you will reach the answer of R12345 equal to 5R plus 26 divided by 6R plus 33. The given circuit is having only one resistance, which is termed as R12345, which is having the meaning that this is the equivalent resistance here. Now the question is in need of finding the range of R in, the range of input resistance. So let us take this to proceed further. So let me call this as equation 1. To find the range of R in, let us take two values of this R. One is the minimum value of R and the maximum value of R. So these two values we are going to substitute in the place of R so that we can find the range of R in. The minimum value of R, which is nothing but 0. Put the R value to be 0 in the equation 1, with which you will get R in value, you will get it to be 26 by 33. You can calculate it to be Rn will be equal to 0.788 ohm, for the minimum most possible value. Next, now we are going to find the maximum value of Rn. For that, let us do some manipulation. So this is the Rn value which we found. So 5R plus 26 divided by 6R plus 33. Let me take the R term will change as 5 plus 26 divided by R. In the same way, in the denominator, the R value I am going to take it as commonly outside. So inside it will become 6 plus 33 divided by R. So the R and R will get cancelled out. The remaining term which is left out is 5 plus 26 divided by R, the whole divided by 6 plus 33 divided by R. Now let me call this as equation 2. So to this equation, let me put upon the value of R, which is the maximum value I am going to substitute. Let me put R value to be infinity in the equation 2. Anything by infinity will become 0. So the equation will change as Rn will be equal to 5 plus 0 divided by 6 plus 0, which implies 5 by 6, through which you can calculate the value of Rn to be 0.833. So this is the range of Rn, with which this is the minimum most value and this is the maximum most value. The range is between the 0.788 to 0.833. This is the minimum and maximum value, or the range of Rn, between which it may vary. Once again, we are into the Proteus tab. We are into the Proteus software to simulate the circuit and check the value what we manually calculated is correct or not. So let us start drawing the diagram. The first step for starting the diagram is picking the devices. Of course, we have 5 resistances. So go to the pick devices, place it as required. So let us place it here, place it here. So one more resistance here, and the other 3 resistance. Now we need a resistance to be vertically placed. These 2 resistances by default it came in horizontal and we placed in horizontal way, but this resistance we need to place it in vertical position. For that, place the cursor over that element and right click. You will see the options for that. You can rotate in anti-clockwise, clockwise, 180 degree, X mirror, Y mirror, all the things you can do. So now I am doing it clockwise, so it is placed vertically. One more resistance in the same fashion in vertical direction, but once I click this and come in and click, you will get, by default it will be placed in horizontal manner, but once again you have to place it and you have to turn it. For that, what you can do, you can copy this and paste one time. For that copying and pasting, keep the cursor over the element, right click, copy to clipboard, and you can click outside, right click, paste from clipboard. So you can place it wherever you want. Okay. Now I am placing it here. So just for information, I am saying Control C and Control V will not work for this case. Okay, you cannot use the shortcut keys Control C, Control V for doing this. So these four resistances are of finite values, but the another resistance we are not given with the value of that resistance. So what we do is we will place a potentiometer. So with that, by doing so, we will study to work with the potentiometer, how to take it and how to connect it, we will come to know. So for taking that element, go to pick devices, we need a potentiometer, type the short form of that pot, and you can see all the variable things, and down at the bottom you can see the active type of potentiometer, this one. Double click, and by clicking that, come into the workplace, click one time. Let me connect it in the opposite way. So now do the wiring. Before the wiring, ohm meter you need to measure out the resistance. Take the ohm meter, place the ohm meter, connect the two ends, connect the two ends, connect this. Don't take a wire from the fixed end, take it from the variable end, because we need the variable function of that potentiometer. So don't connect it in the, that's all. With this wire we have done with the connections. Now we need to change the values of the resistance. This is given to be 1 ohm, this is given to be 2 ohm, this is given to be 3 ohm, and this is given to be 4 ohm. We are in need of finding the Rin value, which is measured between these 2 points. For that, what we have to do, we have to keep this potentiometer with the minimum resistance value, see what is the measured resistance, and we have to keep this in the maximum resistance value, and we have to see what is the resistance of. Keep it to be in the minimum most position, 0%. A potentiometer is nothing but a variable resistance which will have 3 ends, 2 fixed ends and 1 variable end. Now according to our connection, what we have done is we have kept the potentiometer to be in the minimum position, so will get immediately diverted to the variable terminal. So no current will pass through this resistance, so it is called as minimum resistance position. So at this condition, let us start the simulation. You can see the display value to be 0.780, which we got in the manual calculation also by putting the resistance R to be 0. This is the minimum value of resistance between these 2 points, which is called as R in minimum. And the maximum, you have to change the potentiometer percentage to be 100%. Now the potentiometer is at 100%. You can see 100%. Now take the ohm meter display, and it is 0.833. Again, this is what we got, the maximum value of resistance by putting the R value to be infinity. So the minimum and maximum value of Rin was calculated previously by manual calculation, and now it is simulated in the Proteus, and we have cross-checked the value. Though the motive of using the Proteus is not to cross-check the answer, but having an hands-on experience to use the software called Proteus. Once again, we have manually calculated to find the range of Rin, and just now we finished the simulation by using the software Proteus. In this video, we have studied some basics about the network reduction techniques, how to find the mode of connection between two resistances, and we took 2 circuits for that, and we have manually calculated it, and also we have done it in the Proteus simulation, and we found the answers of the manual calculation and the Proteus software simulation results to be same. Once again, hope this video was useful to you. Let me see you once again through another video, through another topic of some other university questions with their solutions in the next video. Until then, I am Masood Ibn Abdul Wahid signing off. Thanks for watching. Thanks for your